Hello and welcome everyone to another video about my development process. I will be talking about my modular system and the latest features that I added and the latest bugs that I solved. First, I will be talking about the bidirectional modulation feature. In most synthesizers where you can set a modulation destination, you can also set it to be either starting at the value where you're currently at with the knob or going bidirectional in both directions. And I added that now too. Then I will be talking about the random modulator. I added a random modulator and I will show you what that means a little later. I will talk about my thread safe pointer system. I'm not really sure yet if it's perfect. I can spoiler you about that already a bit, but I think it might be finished now. Well, you will see. And then I will tell you a little bit about my future plans. So let's run this thing. Okay, so now we are in the actual view and let's just take the LFO and put it here. And now you see it just does what it always did. Being the saw oscillator, put it on sine wave, change the width or like any other parameters, doesn't matter. But one thing that I changed, let's make this a little bit slower, and now let's put it into the middle so you can see it very well. Set it so that it actually goes till the end. So now it goes from 50 to 100, and now I can change this to bidirectional. Yeah, so what I actually did there, it's not very much. I just added an atomic bool for bidirectional to a destination and the corresponding methods that are being used to adjust that or to read from that. And then in process block, well, either something is bidirectional, so this function is used, or something is not bidirectional and this function is used. Now the next thing I want to talk about is the random modulator. You already see it doing its thing here. And let's just put it on the depth, and you see it creating random values, and it also has a rate just like the LFO, can be extremely slow, picking new random values in very slow intervals, and it can be put to tempo sync. But just like with the LFO, that only works when you have a host that actually has a playhead. So we turn it off, and you might wonder, first of all, you might wonder why there are two lines on this thing. That's just because I have not implemented a width parameter yet. So it just generally has width. So it generally creates two curves, one for each channel, if there are two channels, which is the case for the normal standalone version. And you also might wonder, why does it seem to always come around in the middle? Well, that's just because of the bias parameter. When I put it to 50, it will actually create an equal random feeling, and when I put it to near 100, then it will tend to go to the outside. My plan is to add a smoothing to this, so I will add another parameter not only for width but also for the smoothing of the curve, so that there is a low pass filter applied to it basically, so that you can use this modulator on things that should not have a discontinuity like a delay retard, which I will use for my plugin Nell, of course. Just really quickly, if you came here for some actual math, this is the bias function. That's why I like Desmos so much. You can just say A is some parameter with normalized values, and then you can just start writing whatever you want. And at some point, you will end up with a function that you want, and then you just apply it. And you see, when I turn it all the way down, it can produce no other value than 0.5. When I put it on 0.5, then it will just make a normal linear function between x, 0 and 1. And when I put it to 1, then it is equally distributed between 0 and 1. And when I'm very close to one of these numbers, then the fun stuff happens. Think of my plugin Nell, where I want to integrate this. Let's say we choose a bias curve like this. It would mean that the delay would spend most of its time going around these values, but sometimes it jumps up to a completely different value rather spontaneously. And if you imagine that there is a low pass filter on that smoothens it, then it would make the spontaneous jump a little less drastical, and it would just sound like a vibrato that usually does almost nothing, but at some points randomly just pokes out and does some stuff. And the other way around, if we think of this curve, then that would mean that it almost constantly does some stuff, but sometimes, very rarely, it will behave and just produce some reasonable values in the middle. And 0.5 equal distribution would mean that we have a very sober sounding vibrato. Even though it is random, it would be like super clean and it would never create any too crazy things and also no too polite things. So this is basically the polite mode, and this is the crazy mode when you think of a vibrato. That's why I implemented the bias like this. So now let's talk about the thread safe pointer for a while, because I was criticized for my last implementation. The reason why people criticized me for my last implementation was because they said that there was a problem in process block. You know, I had this shared pointer in the release pool, and the idea was that when you are in process block, you can load the current pointer to the modulation matrix into a new shared pointer, so that if the message thread, so basically the graphics thing where you click on stuff as a user, if you do something there that would change the underlying object of the original shared pointer, then the copy of the shared pointer would still work with the old object until process block ends, and only then it would die eventually, because the release pool's reference count would go below that number that I set there. And essentially that's pretty cool. But then someone pointed out that atomic load on a shared pointer does use a lock. You know, everyone says that locks in audio processing are bad because it can happen that they cause a dropout. So the idea was, how do we make it so that even if a lock is used, it is only used when the program actually has to update the underlying object. Let's look at process block now. So just like before, there is the matrix object, which is my so-called thread safe pointer, and it has a method now which is called update and load current pointer, and then it does the thing with it. So at this point it still looks pretty much like before, and if this method still did the same thing, then it would be pretty much the same thing, but it does something different. So let's just see. The first statement is if current pointer is not updated pointer. So apparently there are two pointers now, current pointer and updated pointer. If they are not the same, only then use a spin lock. Choose spin lock to try to enter the lockiness. And this is a very subtle lock. It can create an audio dropout if it takes too long, I was told, but it would usually not do that. And the idea of this implementation is that it's just a very rare case that current pointer is not updated pointer for a reason that I will state very soon. And that's why it doesn't matter if there is a discontinuity here sometimes. But before you get all angry about this statement, let me finish off. So we try to enter the lock, which also acquires the lock if it works. So then we enter the if statement, we set the current pointer to whatever is the updated pointer, and I can already spoiler you, the updated pointer has the new object at this point, and then the spin lock exits. Another case, current pointer is not updated pointer, so we definitely have to update, but the spin lock does not manage to acquire the lock in this method that takes not very long. Then it will just still use the old object, but you know, it's just for one audio block, and that's like no time at all. So next time process block is called, it is very likely that this operation will be true, and then we can exchange the pointers. And since you know this only happens when you change a modulation destination or something like that, that's why this is okay. If you look at my thread safety videos and think this is the general solution that you can use for anything that has to do with communication between the audio thread and the message thread, then you're wrong. Because if you like use this for a spectrum analyzer or something, or anything that would constantly need to communicate with both sides, then you would have a problem, because then this operation has to happen too often and actually create annoying audio dropouts. But you know, if you only have a dropout, if you change a modulation destination, then that's cool. Every time it happens, you make it happen actively, because you know, as a user, you add a destination and you would expect this to work fine. But if it sometimes not works fine, then it's cool. Something that would not be cool would be if it also affected the way it sounds in the audio export or in the render, because obviously you want to be able to always safely export your audio, and that's something where this is just 100% safe. That's for sure, because in that case current pointer will always be update pointer. As you can see, if this works the way I think it does, then it's all cool. If I still made a mistake in here, please tell me. So yeah, there are also some other changes to this. Maybe I could go over that very quickly. At the beginning, current pointer and updated pointer point to the same underlying object. The spin lock is initialized. The release pool gets current pointer, and for that it also gets updated pointer automatically, because you know, they share the same ref count and everything. There is this method, get copy of updated pointer, where the spin lock just enters, and this is different than this method. You see, this is called in process block, where it tries to enter, and if it fails to do so, then it just works with the old object and thinks, yeah, whatever. But this thing will continuously spin until it manages to acquire the lock, and that's why this method is only safe on the message thread, because the message thread can actually spin its lock for ages if it wants to. No problem at all for the audio thread. The audio thread does its thing. So we can do this here. So we can use the lock here to get a copy of updated pointer, which should at all points be equal to current pointer, except if it was just changed by something else, in which case we would definitely want to use this as the starting point for whatever change we put next before it is put into current pointer, of course. So we get copied pointer, return it after exiting the log, of course, because you know, otherwise we would return and it would never call this thing. And this is, for example, used in methods like this, where I get a copy of the updated pointer, or more like of the object inside of the pointer, with a new pointer pointing to the new object, so that this thing is basically independent of everything else. And then I can do stuff with it, like removing a destination, and I will call replace updated pointer with the new thing. Then replace updated pointer with also uses spin lock, enter and exit. It overrides the updated pointer with the new pointer, and it adds the updated pointer to the release pool. At this point, three things are pointing at the thing that we add to the release pool here, which is the new pointer, the updated pointer, and the copy that we have in the release pool itself. When this method ends, the method in the GUI also ends, then new pointer does not exist anymore, just updated pointer, and we only have 2. Our reference count is back to the number 2, and you know, if it goes below 2, then something will die, but at this point it is safe to stay like that. So at some point we will enter process block and see current pointer is not updated pointer anymore. So we try to enter the log, and at some point it works, and we set current pointer to updated pointer, and at that point the ref count of updated pointer goes up again, so that it is definitely safe from getting lost or something like that. By the way, that was also a huge problem in this implementation, because then I had to actually make a destructor that resets the pointers and then releases everything from the release pool that has a ref count lower than 2. Only then that's the case. And if I did not do that, then every time when I closed the application, it would give me a warning that something was leaking. So I fixed that with that. Then there are also some other methods that are sometimes used, like get updated pointer, which just returns the updated pointer. For example, it is used in the timer callback, where you just get the updated pointer that still holds the reference to the same object as the current pointer, and then I give it to all the different objects so that they can update their animations and everything. You see, it's just a const object, so nothing is going to be changed in these methods, and that's why I think that it's okay. Because even if you imagine that process block is just in the middle of using the underlying object, since this is just const and nothing changes, it will just read here anyway, and there will be no interactions that kind of annoy the process in process block. But of course, that's something to watch out for when using my object. So yeah, if you think that this still sucks for some reason, then please tell me about it. Obviously, I want to learn all about making everything as safe for thread in real time as possible. Now I have here this to-do list, and let's just quickly watch this and think of the future things that I will work at for my modulation matrix. Make possible modulators modulate parameters of other modulators. Yeah, at the moment you can put the draggable thingies on every normal parameter like these two, and they will be modulated. But you know, what if you want to modulate one of the other parameters that are somehow related to another modulator? The problem is, I could implement that right now, that I could drag it here and it would create the modulation source and you would see it moving upwards and downwards here. But the problem is, it would not actually affect the modulation at the moment, because the parameters are rendered first in the way I wrote it. You know, the parameters do their thing. Only then the modulators start doing their thing. And then the parameters do their thing again, because basically just because they want to make sure that everything stays in the same range and stuff like that. So the problem is, I have to rewrite some stuff and come up with a way to make it possible that when a parameter is modulated, that the modulation actually has an effect on the modulation of the parameter that is being modulated. I hope that didn't sound too complicated, but that's a very important feature. It is part of the reason why modulation systems like the one in Serum are so much fun, because the user just does not have to think like, oh, does that work? This modulation, is it too complex for the synthesizer? No, you can just go ahead and make very complex fractals of modulation, because whatever. So that's my goal. Destination bias. Yeah, so I had this idea that instead of just giving the options to change the gain of the modulation, also the bidirectionality, that there could be another option for changing the bias of each modulation. I mean, it would be a different bias function than this one, more like one that kind of moves between this and this shape, this, and if you just want to use with one of the modulators, but you still want every destination of that modulator to have a little bit of a different effect, then you could do that easily in such a way. And I always find that that's a very nice workflow. So that's something that I consider for my modulation system as well. Envelope follower modulator. If attack or release, currently smoothing sample-based parameter. Yeah, I think that was a detail about the implementation, that there was some edginess on the parameter changes. I have to look into that. Again, I don't remember actually. Glad that I make to-do lists. LFO modulator, how to handle dynamic parameter changes. What the fuck did I mean with this? Yeah, that's a problem. When I wrote this, I thought it was clear, but now I have a problem with it, because I don't know anymore what I meant with dynamic. What is a dynamic parameter change? What? Okay. But I just keep it here in case that I remember. Now random modulator, just finish the thing, and some motivational words. Yeah, I will do. Thanks. Yeah, and that was my video about the latest progress on my modulation system. I know it's still far from perfect and everything, but it's getting somewhere where I think, yeah, that's pretty cool, and I will actually use this in my plugins. Have a good time, everyone.